Well, this one looks fairly straightforward, right? We don't have some long decimal number over here. So what does it say? It says the log is the exponent. So the exponent is -2, and the exponents go on bases. And what's the base here? The base is 10, right? So this is, now keep in mind what you're thinking in your head is this, right? That's in your head. So you see this -2 going on that base right there. So you're going to write 10 to the -2 is x, but that's 1 over 10 to the +2 is x. So x is equal to 1 over 100. So there's a perfectly good answer here, or I suppose you could write it like this. You could write 0.0 tenths, hundredths, right? You could write it like that. Now in problem 37 back here, we were looking at common logs. Now in 41, we're looking at natural logs. So you want to see through this notation. You don't want to have to write this every time. ln x really means log base e of x. That's equal to -1. Right? You don't have to, you might think this. Right? We'll put that in our head, right there. That's in our brains. But what we're seeing, this is what we have, this is what we see in our heads. The logarithm is the exponent. So the exponent goes on that base, and the base is e. So it's e to the -1. That's equal to x. So I can get an exact value here if I write, well, all right, I'll write it this way. But what is e to the -1? If I get rid of that negative exponent, it's 1 over e. Now, just so you know, I'm using a TI-84, and on my 84, if you look down the very left column, you'll see a key that says ln, right, natural log, and right above it, it says e to the x. So what I have to do is, if I want to use that key, I'm going to have to press second, all right, so I press second, and then I press that ln key, and that gets me, the second gets me right to that function right there, and then that gets me e, and then it's waiting for a power up here, and then I type in -1. Now be careful that you type in -1. Don't type in -1. Type in -1. The negative is down at the very bottom right. It's not the minus key. So when I did that, I got this. I got 0.36787 ... If I round it off, I could say this. X is equal to, I'll round off to maybe 3 places here, so I'll round that up. So 0.368. 43 is interesting, right? Because it's got logarithms on both sides. So why don't we get all the logs on one side, the left side or the right side. Might as well get them on the left. So I'm going to subtract this one here. So I'm going to write it as the log of x minus 2 log of 5 equals 0. And now I'm going to combine these together as one single logarithm. So the first thing I'm going to do is take this 2 here and bring it up as an exponent. So I'm going to rewrite this now as the log of x minus log of 5 squared, which I just happen to know how to do, right? So let's do it. So it's going to be the log of x minus the log of 25 equals 0. Now I can use my properties of logarithms to put these two together. So you have to remember back a few sections. We have a minus sign here. Now a minus sign comes from a quotient. So we have it, this is going to combine as a single log. So I'm going to write this. I look through it, I see a minus sign, so I write a fraction bar right away. If I don't see a minus sign, no fraction bars. But we've got a minus sign right here, so fraction bar. The positive goes on the top, so the x goes on the top. The minus, that goes on the bottom. So this is going to be x over 25 equals 0. So this is looking interesting now. What we've got is that the logarithm is the exponent. So the exponent is 0. But exponents go on bases, and the base here is 10, right? The base is 10, so we get 10, if I can write it here, we're going to get 10 to the 0 equals x over 25. But what's 10 to the 0? You know what that one is? That's a 1. So 1 is x over 25, and now if you just multiply by 25, we've got it. X is equal to 1 times 25 is 25.